Just a second. Really, 10 seconds. Okay, I'm back. All set. Oh, you are in the webinar. Very good.
Yeah. I will give a couple of minutes for the release video.
That's fine. That's fine.
Okay, we'll go ahead. Okay. Welcome back, everyone, after an energetic lunch break here in Sri Lanka, Reuven. So it's lunch after the lunch time here. So I'm delighted to introduce our next session titled, What Happens When You Import a Module? So with our esteemed speaker, Reuven Lerner. Before we dive into the session, let me provide you a brief overview of the session. We all know modules are an integral part of Python, allowing us to reuse code and leverage publicly available modules. We frequently encounter importing statement in our programs, but have you ever wondered what happens behind the scene? Yes. How does Python locate the module? How does it determine whether to search for the module? And once found, how does it load the module into memory and assign its attributes? Okay, let's, in this session, enlightening talk by Reuven Lerner, the speaker today, will guide us through the intricacies of the module importing process in Python. Also, let me introduce our speaker. Reuven Lerner is a seasoned Python trainer, renowned for his expertise in the field. He conducts training sessions worldwide, both in person and online, and has delivered sessions in US, Europe, Israel, India, China, and beyond. Reuven's extensive experience includes teaching Python at companies across various industries. He is the author of Python Workout, a comprehensive collection of Python exercises with detailed explanation published in 2020. Residing in Israel, Reuven shares his passion for Python while balancing his personal life with his professional life. Now, without further ado, let's welcome our speaker today, Reuven Lerner, to uncover the mysteries behind importing modules in Python. Please join me in welcoming, and Reuven, the stage is yours.
Thanks so much. Take us there. Thank you, everyone. Can I start my video? No, it's not letting me start my video. Any chance I can do that? I'm not sure if I can. I'll share my screen in a moment as well, but you might want to see me. Yeah, it has been known to happen. No, still cannot start it. Looks like there's some so it looks like Zoom is not allowing me to.
Okay. That's what, but we can see a picture of yours here.
All right, well, let's see. Let's see if I can share my screen, because sometimes those are linked one to the other. Let's find out. So I'm going to do this. And I'm going to share that. Am I going to share that? No, I'm going to share this. Okay, let's do this. And then let's see if this works.
Yeah, here it goes.
Okay. And you
Yep.
see the slide?
Yeah.
Excellent. Okay.
Perfect.
Fantastic. And then let me just pull up here and here and here. So I see the chat and the Q&A and so on and so forth. Okay. So I am definitely, first of all, hey everyone, welcome. I would say good morning because it's morning here in Israel, but you just had lunch. So
Yep.
good afternoon, whatever time it is for you, also for people around the world. So my name is Reuven, and I'm going to be talking to you now about what happens when you import a module. Let me see. There we go. And as was already said, I teach Python. That is what I do full time. I've been doing it for many, many years. I do corporate training, so I fly in around the world, or I do it on WebEx and Zoom, help companies improve their Python. I have video courses. I do hybrid courses that are partly in person, partly video. I have this thing called Weekly Python Exercise. I have books. I have the Python workout. I have Pandas workout. And then I have several newsletters, the two of which are probably most interesting for you folks is I have a newsletter called Better Developers, and that's all about Python and software engineering. And then I also have a new one called Bamboo Weekly, which is all about pandas and current events. So I take a topic from the news, I take a topic in pandas, and I examine it together. On Wednesdays, I send questions, and on Thursdays, I send answers. So enough about me for now. One of the most important topics, or one of the most important phrases in programming is dry. Dry stands for don't repeat yourself. And we talk a lot about how we want to dry up our code. That is to say, if I have code that does repeat itself, how can I remove that repetition? And we don't think about it necessarily, but we do this all the time. So first, if I have the same code line after line after line, I don't have to have that repeated. Instead, I can just use a loop, typically a for loop. We could use a while loop, but write loops. What if I have the same code repeated in several different places in a program? Well, then I can use a function. And then, of course, I can have many references to that function, many calls to that function, but the code itself is only in that function. But what if I have repeated code in several different programs? Then I'm going to use a library. And libraries exist in just about every programming language. I'm hard pressed to think of a language that does not support libraries. Well, in Python, our libraries are called modules, and they are usually, not always, but usually files containing Python code. But they also do one additional thing that's really, really useful. They provide us with namespaces. And we're going to see how importing addresses both of these issues, both loading data into Python so that we can use it and reuse it, and also the namespace issue so that we don't have what we call namespace collisions, so that names in the module don't collide with names that we've defined elsewhere. So let's actually get our heads a little bit dirty and let's import a module. And the way that I can do that is, of course, with the import statement. So for example, here I say import random. Now, it's important to realize, to realize that import does two different things. First of all, it creates a new module object. And second of all, it assigns that new module object to a variable. So it's actually doing two separate things here. And this is similar in many ways, similar to what def does. When we use def in Python, it actually does two different things. It creates a function object, and then it assigns that object to a variable. So in the same way here, import is creating a new module object and assigning that to a variable. Now, a few things to notice about this. First of all, import is a statement. It is not a function. We just say import and the name of the module we want to import. So there are no parentheses. In fact, if you use parentheses, you will get an error message. The next thing is we give the name of the variable we want to create. So when I say import random, I'm defining the random variable. I do not give it a string. I don't say import and then in quotes random. I don't give it a file name. Right? In many, many other languages, when I import or use the equivalent, I am saying this is the file that I want to read. But that's not the case in Python. In fact, in Python, there is no standard way. There are ways to do it behind the scenes. But the import statement itself does not take a string. It does not take a file name. So you cannot directly tell Python what file you want it to load. I know that sounds really weird, but it is the truth. And so modules are objects because everything in Python is an object. So if I say import random and I say, hey, what is the type of random? The answer is module. I should add, by the way, that module is not a name that is defined in the global scope. It's not in globals, it's not in built-ins. So even though it says, oh, I'm a module, that doesn't mean that you can simply use the word module wherever you want. This is the name that was returned, the type that was returned from saying type of random. So module objects are actually really simple. They are basically namespaces using attributes, and modules don't have any methods. Now, what does it mean to have a namespace? Once again, the idea is, let's say I import 3 different modules in my program. I import A, I import B, I import C. What if modules A and B both define the same variable? And what if B and C define the same variable? I don't want them to collide with each other. Moreover, I don't want them to collide with names that I've defined in my global scope. So a namespace is sort of like a surname. A namespace ensures or reduces the chance that we will have some, the same name used twice and confused for itself, right? So basically our modules here are acting as namespaces. So if I import random, all the names that were defined in that random module will be available as random dot something. And attributes in Python, as we'll see in a little bit, attributes are names that come after dots typically. Okay, so what if I want to import a module, but I want to give it a different name? So I can use as, and I can say import random as R. And once I've done that, the only difference between saying import random and import random as R is the variable that's created. So if previously I assigned the module to the random variable, now I'm assigning the module to the R variable. But what happens if module A imports B and module B imports A? Whoops, here we go. We don't want an infinite loop. Well, that's assuming you're not a consultant, because if consultants charge by the hour, then infinite loops are infinitely profitable. But this does not happen. Python only imports a module once per session. It will always define the variable. So if A imports B and then B imports A, so A will import B and B will be imported. Yes, that will happen. And then the variable B will be defined inside of A. But what happens when we load B? Well, what happens when module B runs? Well, then it's going to say, I'm going to import A, but then it says, wait, A is already loaded. So it does not actually load the module. It just defines the variable. So import will always define the variable, but will not always actually load it from disk. But wait a second, how does Python know if a module has been imported? Right? It's very nice to say, oh, it only loads it if it has to, but how does it know? And the answer is sys.modules. And this is a dictionary. Why is it a dictionary? Because we in Python love dictionaries. We use them for everything, including for caching. And so this is the cache for Python modules. And the keys are the strings, which are the modules' names, and not the names that we give them as variables. So if I say import A as B, the key will be A. It will be the actual module name, not the name that I've given it in my local directory. And the values are module objects. And if you ever wonder, why does Python allow absolutely positively any type of object to be the value in a dictionary? This is one of those reasons. So when we import, Python checks to see if the module is already there. And if not, then it imports the module and adds it to sys.modules. And then it assigns a global variable to the value. So how big is sys.modules, right? Like how many modules do we have loaded by default? So if I use the standard Python interactive shell, the one that comes with Python that everyone knows and loves or knows and sort of deals with, I say import sys and I say, hey, what's the len of sys.modules? And the answer is, oh, I didn't say here. Huh, that's so funny. It's like 70 or so. I didn't even notice that I didn't have it on the slide. It's about 70. IPython, which is a fantastic interactive, like sort of superset of the Python interactive shell, 646 modules. So it's about 10 times what we would have in the standard sys. But if I use Jupyter, which is always fantastic because it's web-based and everything, then it almost doubles it again. Then I have more than 1,000 modules loaded. So basically, you can see that these other REPLs, these other read eval print loops that we can use, yes, they are nice. Yes, they are friendly. Yes, they are terrific in many, many ways, but they also use many more modules. And that's where a lot of functionality is indeed stored. Now, I'm going to show some simplified versions of what happens when we import a module. And don't really run this code. Instead, you should be using import lib. Import lib comes with the Python standard library. That is to say, when you install Python, you get import lib automatically. And import lib is designed for exactly this. It implements the import system. And it's meant to be read and studied and used. And I'll refer to a few places later on. But right now, I just want to show you some pseudocode for it almost kind of sort of works to do what importing does. So I'm going to define a new function. I'm going to define it my import. And obviously then it's not going to work like import, because import is a statement and this is a function, but this is to give you the idea. And it's going to get a module. It's going to get, module name, not module. I really should have checked this a little more carefully. So basically it says if the module name is not in sys.modules, or I guess it should just be if mod, right? So if mod is not in sys.modules, so if the module that user wants to import is not in the modules, then we will get the module and we will assign that module object to sys.modules of mod. Then I'm going to do something really wild. Then I'm going to say globals mod equals sys.modules. What the heck is globals mod? And globals mod, basically, the globals built in gives you a dictionary, once again, a dictionary with all of the global variables in, all the global variables in Python. And as a dictionary, you can then assign to it and you can retrieve from it. I know it seems really weird. You should never do this in real life. But if you go to globals, parentheses, and then give it in square brackets a name, and then you assign it a value, yeah, that will actually assign to the global variable. But there is something a little weird here. Like, what the heck is this get module function? Like, what's going on there? And we'll discuss this in just a little bit, like what it has to do. So this is nice and everything, but it's not quite what we talked about, because we said that we can import, but we can also import as. So let's see that. Here is import as pseudocode. And now I'm going to say def my import just as before. We're going to take mod, but we are going to take an optional alias. And then I'm going to say if mod not in sys.modules, sys.modules mod equals get module mod. In other words, load the module if it is not already in our cache. And then I say if alias is none, so if no one gave us an alias, then we'll say alias equals mod. Then we will simply define the variable with this, with this name. But if there's an alias, then we'll use that. And then I can say globals of alias equals sys.modules of mod, and I have assigned to it. So import and import as are basically all about, let's load the module, whatever that is, which we will deal with in a little bit, and then we assign it to the cache, and then we move on. Well, what happens if my top level program says import A, and then module A says import B, and module B says import A, right? We talked about this a little bit before, but now we're going to go into more depth. So what happens? Well, our program says import A. A is not in sys.modules, so A is loaded. And then the global variable A is assigned to sys.modules A. Fantastic. So now we have in A that module. So far, so good. What happens now? Well, module A imports B. B is not in sys.modules, so B is loaded. And the global variable B is assigned to sys.modules of B. But then when B runs, module B imports A. And here it says, no, A is already in sys.modules. It does not need to be loaded. But the global variable A is assigned to sys.modules of A. So we are assigning to, now you might think, wait a second, what is this that we're defining like 3 different global variables? Global does not mean really global in Python. Global means inside of the current module. So yes, we've defined 3 global variables, unless, yes, that might make your head spin a little bit, but the first global is the actually global at the top level. The second global is inside the module A, and the third global is inside the module B. Okay, this is fine and everything, but global variables, this is what I was just saying, right? In many languages, the global variable is available through the entire language, but each module can have a different global, each module has its own globals. So module A can have a global X that's totally different from module B's global X. Which namespace are we in? Which globals are we referring to? That is always available via the dunder name variable. Dunder name is always available, and it says this is the namespace in which you are currently loaded, and thus the namespace whose globals you are working with. Now, the first namespace, when you first come up in Python, is called dunder main. That's a string. And so that's why we can always check, and you've probably seen this. What is, in your code, if dunder name equals dunder main, what is that doing? It's checking to see, are we the first program that is being loaded and run, or have we been imported? And that allows us to make that distinction there in our imports. Okay, so let's rephrase things now. Our program says import A. A is not in sys.modules, so A is loaded, and the global A is assigned to sys.modules of A. So far, so good. This is a global variable. Then module A imports B. And then I'm going to say here, A.B is assigned to sys.modules. This is a more accurate way of describing what's actually going on. And there's no distinction really between the global variable B in namespace A and B, the attribute in A. But it's easier to think of as an attribute because that's really what's going on. A.B is assigned to sys.modules B. And when I say that module B imports A, then B.A is assigned to sys.modules A. Okay, so we've seen now how we can load a module in the simplest possible way. I say import, it defines the variable, it assigns it to the module. What about, though, if I want to import specific names from the module? So you've probably seen this. You've probably seen from random import randint. Here is the question that surprises people the most when I answer it. Does this save memory? No. If you are using from import in order to save memory in your programs, stop. You are not saving memory. Does it still load the entire module? The answer is yes, 100%. But wait, how can that be? Why would that be? Well, it's actually very simple. When I say from import, I have to load the module because otherwise, what is going to be in the cache? I know it sounds kind of weird. So if I say from random import randint, Python checks to see if random is in sys.modules. If not, it loads the entire module and puts it in sys.modules. Sys.modules does not contain half modules. So either the module is already there and is using memory, or it's not already there and we have to load it. Either way, though, the entire module is loaded into memory. We're not loading a single name or a single function. And after it checks to make sure that the module has been loaded, then and only then it defines randint as a global. But random is not defined as a global. Okay, random is, if you just do from random import randint, it will load the random module. It is available under sys.modules, but it is not actually defined as a variable. So here is some from import pseudocode, sort of like what we did before. So I'm going to say now, if mod is not in sys.modules, right? So if we've not yet loaded this module, then let's load the module. Sys.modules of mod equals get module of mod. Fantastic. But then I'm going to define the names that I want for one name and names. And then I say globals of one name equals get adder sys.modules mod of one name. Wait. What the heck is that? Well, our module object has all of those attributes defined. So if inside the module it has randint defined or is x defined, then when I say sys.module, when I say get adder of sys.modules mod one name, that's basically saying get me x or get me whatever it would be, randint, as an attribute or the attribute value from that module. So because attributes are defined on module objects, then we can get it back. Okay, that's nice. But wait a second, there's another version of this. We can also say from import as. So I can alias things in this way. Well, now what? Well, basically, I'm going to fix this right here. Hold on a second. This is really annoying me. There we go. There we go. And go back to playing this. There, now it works just fine. Okay, I should have done that before with the others. So now if I say from import, I'm going to take a module, but then I'm going to get KWRs, names and values, right? Because I'm going to need to know which names am I going to want to define and how am I going to want to define them. So I'm going to say, define this name as that name and this name as that name. I'm just going to go through each of the KWRs, each of the keyword arguments, and I'm going to say, I am now going to take this attribute value from the module object, which is already stored in sys.modules, it's cached there, and I'm going to assign this alias in the globals. Oh, the host has to start your video. And now you can see me, woohoo, okay. Well, that's refreshing. Okay, so now what? So now, what does get module do, right? Just to remind you, here and in all of my pseudocode, I've been pretending that there's this get module function. And what that's going to do is take the name of a module and return a module object. That seems like it's a lot of work, no? Well, yes, that's why it gets its own function. And what does this module do? Well, simply put, this function is going to get a module name, and then it's going to load a file. So this is my pseudocode function. It takes a module name and needs to do two things. It needs to find the file, and then it needs to load the file for our module. And it returns a module object. So the thing is, how am I going to find the file? Where is the file going to be located? And then once I find the file, what does it mean to load the file? Well, it turns out that there is actually a function called getModule. Actually, it's not called getModule, but it does the same thing as getModule. It's called importlib.import module. All right. And so if I want to, and I don't suggest you do this in real code, I can say import lib.import module, and then I give it a string. And that string is the name of the module that I want to load. And then I say, tell me, what is the type of R? Oh, it's a module. And then can I say r.randint? Absolutely. Absolutely, I can. So the good news, it works. This function does what I want. So I don't need to implement it, right? But yeah, but maybe we want to understand it, because how does Python actually find modules, right? Because again, if I say import random, I'm not telling it to load a file. I'm saying I want this random module to be defined. So where's it going to look for files? And the simple story, which I told for many years as a trainer, is that Python looks in sys.path. And sys.path is a list of strings, which are all directories where Python will look. And it's defined when Python starts up. And the first match wins. And so namespace collisions can lead to surprises. Now, what does this mean? This means that we're going to have a list of directories. It's sort of like if you use the Unix shell, or even in Windows, if you use the CMD terminal. Basically, when you enter the name of a command, your operating system is going to look through your path, one directory after another, and the first directory containing a name that matches, that wins. Now, this can cause all sorts of problems, but once you configure your system correctly, it's actually usually a pretty good thing. And namespace collisions, very, very bad, right? So if I decide that I'm going to find my own module called random, and I'm going to put it in my current directory, as you'll see, the current directory always comes first. And so that's going to cause some trouble. So let's see a little bit about sys.path. So if I start up the Python interactive shell, and I just say print / join sys.path, right? What is there? Well, first of all, the first element there is actually invisible, but it's the empty string. And the empty string means search in the current directory. Always, 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 Python will search in the current directory first for any module you've asked it to load. And so it looks at the current directory, but if it cannot find anything in the current directory, then it looks through these locations in sys.path one at a time. Notice they're all directories except for the first one here, or the first non-null one here, non-empty one here, which is a zip file. Is that okay? Can we search for modules in a zip file? The answer is yes, it works just fine. So sys.path 0 is usually the program's directory. It's not necessarily your working directory, it's where the program is. And it can be the empty string. But no matter what, the program's current directory is always the first place we search for module files. And I had problems with this years ago when I would teach courses, and I would ask people to, we would do this little program, like it's an exercise to choose have the computer choose a random number, and then we would present the number, and then the person should guess. And we use the random module, and the random module is called, of course, random. So we say import random. But then some people inevitably would call their programs random.py. And when inside of random.py, you say import random, well, it first looks at the current directory. It found random.py and loaded itself, which led to hours of amusement. And by amusement, I, of course, mean people being very, very confused. So what else in sys.path? Well, the next thing, as we see here, this is from the last version of Python from 3.10 when I prepared this talk, but it'll be the same thing in 3.11. Basically, then we have the standard library. And the standard library is what comes with Python. I mentioned before, it's a large number of modules that come with it. And the standard library here is located in a combination of this zip file, that's the first one, and then directory, the second one, and then libdin dynamic load. For dynamic loading things, that's for modules that have a non-Python component that need to be stuck somewhere, so they're stuck there. So the standard library, as I said, normally comes next. Standard library modules are not imported automatically, but they're always available via syspath, which means they're always available if you import them. Now, why are they not imported automatically? People often ask me, like, why do I have to say import to something that came with Python? And the answer is simply put, memory, right? Why should I import things that I'm not going to use? It's going to use up names. It's going to use up memory, right? Each of these modules does require memory. So there's some things called built-ins that are automatically loaded, but most things are not, but they're always available via syspath, and you just import them. Okay, and what's this last thing here? This last thing is site packages. That is always going to be on your path, at least in modern Pythons. And site packages, this is where pip installs packages into. So when you say, go to PyPI and you find this amazing package, it's going to do whatever you need. Then you say pip install, blah, 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 blah. That and blah, 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 blah is installed into site packages. And Python knows that when it's doing import to search in that directory. And it usually comes after just about everything else. Well, this raises an interesting question. So if I want to modify where Python searches for modules when I do import, maybe I can do list.append and just add a bunch of directories to sys.path so that I can have a custom path. Don't do that. Don't do that. Instead, what you should do is you should set the environment variable Python path. And whatever you set here, or whatever value or values you set there, those are set at sys.path1. In other words, if I set export Python path equals /hello/goodbye, and then I start the Python interactive shell again, so I do that export on the Unix command shell. So now we have the empty string as usual, and then /hello and /good/bye. And this, of course, comes from Python path. And then we have the Python standard library, and then we have site packages, which means that basically, when you say import now, it will first look in the current directory, then look in hello, and then look in goodbye. By the way, do hello and goodbye exist as directories? No. Excuse me. They do not exist. And so Python will look for them, but if they're not there, then it'll just sort of continue and skip over them and say, well, yeah, another dumb human. And now the pseudocode version. So how is this going to work? And you can see that our import system is getting more and more complex. So my import, it's going to take a module and an alias. And first we're going to say if mod is not in sys.module. So if it's not in sys.modules, what are we going to do? We're going to have to load it. So I'm going to say now for directory in sys.path, I'm going to look for the file in sys.path. I'm going to say, can we find, for file in sys.path? We're going to create the path we need. We're going to say if it exists, then we're going to load the module and break. What happens though if we go through the entire sys.path and we do not find the module we're looking for? Oh, then we're going to raise an exception, raise the module not found error. Now, load module is still something that we haven't discussed, right? So we're going to need to deal with that, and we will discuss it soon. But I hope that you're seeing how we're expanding how our module works and how it's loaded up. Well, there are some issues with this story. Some items in sys.path are not actually directories, right? They're zip files. Another problem is that modules are stored in many different places. And also, how is it that if you have a file called time.py in the current directory, which is a module, when you say import time, it still imports the real Python time module. It does not import your time.py. In fact, there's no way for you to import a file called time.py. What the heck? What about PYC files? What's going on with them, right? What are those and how they work? And what about packages? By the way, spoiler alert, we're not going to talk about packages. So the solution to all these problems is finders and loaders. And these are two special kinds of objects in Python that are used whenever we use import. So finders ask, does the module exist? Which loader should be used? And it returns a special kind of object, a module spec, a module specification, which contains a loader in it. In other words, if I call a finder and I'm saying, hey, what should I do with this module? The finder then will say, oh, I found it. And this is how to load it. And this is from where. And the how to load it is done through the loader object, which creates a module object, executes the module file, and populates the module object. And if you're thinking, wait, what do you mean executes the module file? Yeah, we're going to get back to this in a moment. There is something called an importer, which does both finder and loader work. Okay, but wait, how do we find these finders? How do we find these importers? And the answer is we have something called sys.metapath. And the metapath is where Python puts the finders and importers, so that if we go through the metapath, then we can try the first finder, the second finder, the third finder. And each of these implements the find spec class method. So basically what we can do is go through the metapath, one element at a time. We're going to try to find a finder or an importer with which we can load up our module. If we find it, then it works great. And we get back a module spec telling Python how to load the module. So this find spec method tells us, otherwise it says module not found. So each of the finders in metapath gets a chance to try to load the module. If it works, great. If not, we go on to the next one. If we get to the end, we get an error. So what if I want to say here finding random? Let's do some more pseudocode. So someone says import random. So how's that going to work? Well, I'm going to say for one finder in sys.metapath, right? And then I'm going to say here, well, let's print the finder. And then I'm going to say one finder find spec. So what does that mean? I'm calling the find spec method on this finder object, which is fine because it is a class method. I'm going to say, I want you to find the specification, module specification, and then print it. And if we found it, if we found the module, then break. So if I now say finding random, what's going to happen? What's it going to print when I run this code? It's going to say, well, I have the distutils meta finder and none. All right. And then it's going to say, well, I found this, built-in importer, none. So what is it saying? It's saying I did not find random via the distutils meta finder. I did not find random via the built-in importer. Let's try the frozen importer, none. Let's find the pathfinder, the normal one. Oh, look at that. We got back a module spec. In other words, Python went through, and when I say import random, I'm not aware of this. I don't think about this at all. I just say, okay, I'm importing random. But actually, Python tried 4 different places until it actually found the module and thus was able to get a module spec based on it. What if I save time, right? I mentioned before that time is kind of special, right? What happens if I do that? Well, it's gonna try the meta finder. It's gonna say, okay, I'm trying the meta finder here. I'm trying the built-in importer. Oh, it stops. That is why, even if you have a file called time.py, the built-in time module will take priority because the time module is not written in Python. It's not loaded in a directory. It is a special module that's available in frozen import lib. And that just makes it load faster and get priority. So wait a second, what modules are already loaded when we start up Python? These are the ones that are in that, let me just see, in that, that's not what in the built-in importer, that's right. So what are loaded by the built-in importers? These are the names basically, right? So we got built-ins, Erno, fault handlers. These are the modules that are already available. So what if I say math, right? I want to find the math module. So it's going to say, okay, finding math. We're going to look for distutils meta finder, none. Built-in importer, none. Frozen importer, none. Pathfinder, oh, there we go. So what does that mean? It means that it found it in the path. It found it on disk in a directory, which is exactly what we would want and expect, right? That's sort of the normal case that I would expect. All these other things are just kind of weird. So what is in a module spec object? Now that I've told you that the module spec is returned. So it is attributes that tell Python how to load it, from where it has the name, the origin, whether it's cached, who is the loader, what's the location, where's the parent. It even says, where should we search for submodules? So we can use the specs loader name to create a module. So if I say here spec.create module, and this is an actual method that exists on the actual spec object. If I say here spec.create module spec, I get back a module in theory. If you don't get the module back, then you need to create the module object yourself and assign a bunch of attributes to it. So this create module is like setting up a template. Okay, and much easier way is, of course, to use import lib. And I can say import lib util module from spec, and this creates a module object based on a module spec. And it even populates the important attributes. So if I say deriv mod, I get under cached, under docked, under file, and so on and so forth. But wait a second, our module object exists, but it doesn't contain any of the definitions. Right, for this, we are going to need to load code for the module. So you understand what I'm saying? That basically when we import the module, we get this module spec object. The module spec has these special names defined, but doesn't yet have our module's names defined. So how are we going to get that? And the answer is we have to execute the module file. And I know it sounds crazy, right? Many people are like, no, that can't be. That can't be. I have to I just want to import one particular thing. I want to do from import as, not fine. But as we said before, this means that you have to actually execute the entire module start to finish. So if the module is a variable, well, the assignment needs to run. It has a function, def needs to run. As a class needs to run. So when we load a module, when we import a module, it runs top to bottom. And how does this happen? It happens thanks to exec. Exec is one of the most powerful and dangerous functions in Python. You pass it a string and it executes that Python code. And if you want to, you can do very destructive things in it. So if I say, here's a string, hello, Reuven, goodbye, and then I exec it. So exec will say, okay, hello, goodbye. And if I check, then what is the value of name? It'll be Reuven. So it basically, yeah, I mean, it'll execute whatever code you want as if you typed it yourself. But you can also pass a second argument to exec. And if you pass a second argument to exec and it's a dictionary, then it does not start to pollute our global namespace. Rather, it will put all these definitions into a private namespace, into a dictionary. So if I say here, D equals curly braces, then exec S of D, well, then it's going to say hello and goodbye, just like before. But it'll also allow me to retrieve based on that dictionary. So how does this help? Well, module objects have a dunder-dict attribute, and any key in this dict is an attribute. So if our program reads the source code from the module, executes it with exec, passes a second argument, the module's dunder-dict, well, then we don't have to worry about global assignments, do we? So basically, I can do this myself, but why work hard? Loader objects have an exec module function, which works just exactly this way. So if I say spec.loader.exec module of random, it is going to then load up the random module, just as I did before. And then I can run it, random.randint 0 to 100. And we get it. That is a lot. Bet you didn't think it was that complex, but actually it's even more complex because you can have custom finders. You can have custom loaders. And I spoke to someone last year whose company actually implemented custom finders so they could use SHA-1 for some security purposes. Didn't quite understand what he was talking about, or don't remember it. I think I understood then. But you could really modify any of these pieces. So to summarize, what happens when you import a module? A lot. Python checks if the module has been cached. If so, it returns the module and assigns the variable. If not, it just goes through the finders in sys.metapath. If none of them finds the module, you get an exception. But if it does find a module, then the finder that works returns a module spec object. And then Python creates a new empty module object, and it uses the loader part of the spec to exec the source code into the module's dunder-dict, making globals into attributes. And wait, we didn't talk about packages. Yeah, that's right. We don't have time to talk about packages, but just so you know, packages are directories, not files. Several more attributes like dunderpath are populated. You need to keep track of levels where you are in the directory structure, and this adds complexity for sure, but does not change the overall structure of what I've defined here. So we've reached the end. If you have any questions, I will be super, super happy to answer them. I'm always happy to hear from people online, on Twitter, the YouTube channel, right? And I've got my 2 newsletters, and anything that people have to ask, I would be very, very happy to answer. I don't know how questions work here. I say you need to moderate that.
Yeah.
Okay.
I guess you can drop your questions in the Q&A session. So as you guys are aware that there is a Q&A tab that you can use to.
If you don't ask questions, I'll have to ask you folks questions. That'll be very embarrassing.
To start with myself, Reuven, so this was an enlightening one because as I always use this import function and I have no clue how this works in the background. So I would say like there is no week that I have missed to use this import function. So it was always there on my programs always, but I have never had this much of depth information about the import function, how this works in the background. So thank you very much for that, first of all. So I had
my pleasure.
Yeah,
I'll tell you, a lot of the things that I teach, a lot of the talks that I give are because I teach so much and people ask me questions, and it's always forcing me to sort of think and rethink what I know. And so I also, like, how many years have I used import? I've been using Python for like 30 years. And at some point a few years ago, someone asked me what's going on. And I just, I found out about sys.path. I said, oh, that must be it. And then as I started scratching the surface, I realized, wait, that's not it. This turns out to be very, very complex under the surface. So yeah, and here's a little hint, by the way, to people who want to give talks at conferences. Propose talks on things you want to learn more about, not things you are experts in, because you will force yourself to learn, and you will learn like incredible things. Like I feel much more enlightened now than before I started researching this talk. So yeah.
Any other questions, guys? So if you have questions or any feedbacks for Reuven, he's always welcome.
People ate too much for lunch, I guess.
Yes. And also, Reuven, so I had no clue that you have completed your in your last year session, I think like you were working on your pandas workout book, so I didn't refer to it yet. So hopefully I have to work on it as well.
So I will tell you, the Pandas workout book is almost done. I'm terrible. Like I think they're gonna send out like like a hit squad against me. I'm so bad at this. But I am currently in the like second edits of the book. So I've got to turn in, I'm hoping Sunday or Monday to turn in the last chapter there. Then it's going to go to experts in the field and it'll go to some more editors. And hopefully in like a month or two, it'll be out for real. What a relief that'll be. But I'm feeling really good about the book. Like I really am proud of the exercises in it. And people who've been reading the early version say that they enjoy and they've learned a lot from it. But the publisher already asked me if I want to do another book. I'm like, wait, I have to see my family sometimes.
Totally understandable. Yeah, fine. Yeah. Okay, then if you guys have any question, you can drop it on the questions and answers tab. If you guys are good, we can go ahead.
All right, I guess they are stunned into silence.
Yes. Okay, and thank you very much for the session, Reuven. So it was like, for me, it's enlightening. So there are things that I have just heard of, and I just got to know about how it works, and those things are enlightening. So thank you very much for that. We explored the inner workings of module imports and their significance in the code, and also let's remember that understanding the module imports and empowers us to leverage external code effectively. And once again, it's a special thanks to you. So thank you for the session. Thank you for the detailed session that I would say. And hopefully we will have you in upcoming our webinars too. So it is always a pleasure to have you with us.
Thank you. Likewise, thanks for the invitation, and maybe, hopefully, even in person, maybe next year. That would be great fun.
Yeah, we are planning. So thank you.
All right. Bye for now.
Bye-bye.
Thanks so much.
Bye-bye.
Okay, we'll end the webinar here. Thank you.
Okay, thank you.